Hey there, welcome to episode 87 of the Let's Innovate for Vegas audio program. I am your host, Dan Hugo, Managing Director of the Innovate for Vegas Foundation, a 501c3 public charity, nonprofit in Nevada. How cool is that? The date, we are recording this today at 12:47 p.m. It's just afternoon. Okay, well, it's very near 1 p.m. on October 15, Tuesday. 2024. Today's topic is kind of weird. You're going to think right away that I must be talking only about software, but mostly not. I mean, you can do these with anything, and that is test and debug. In fact, everything. Test and debug everything. Hopefully, wherever you found this episode, you are able to see the episode description, which contains the show notes. There are 4 links and a summary that I will read to you. That's my usual intro, I think. So yeah, wherever you found this episode, be sure and locate the links that are contained within. I have updated the links slightly, not pointing to GitHub anymore. I mean, I will in the future, but for the moment, I'm just going to be linking to the top level websites, which as I am speaking into this microphone are not put up yet. But that's not an undertaking that will take more than minutes. The true task will be making the content interesting and useful. That will take a lifetime. But either way, keep that in mind. New URLs for 2 of the things. So let's get this started. The summary of today's episode, obviously, we test and debug and test again and debug yet more our various software applications and whatnot. And then you, the customer, the user, does more testing for us. I'm going to refer to us as the people in the software development universe. We rely a lot on you to do a lot of our work for us. Hey, this doesn't work. Oops. Can you send me a bug? Can you tell me what phone you were using? Can you tell me what browser you were using? Can you tell me what the weather was like on the day this happened? So we ask a lot of the people who pay for things, although I will say it's humorous that free applications in your favorite mobile device application store, Play Store, iTunes Store, whatever it is, free applications will sometimes get maligned for bugs. I think the only bugs that are worthy of maligning are related to advertising and poor user experience, but I digress. Users, a lot of work is done by users to beta test. Like, is this really done? It will be. The same goes for everything else, though, not merely software. By the way, this is not I've added. I'm winging it in this summary. The same goes for everything else, not merely software, and we can always do better across the board. That just means if we care about what we're making, and this is the take home, we'll just do it at the beginning. If we care about what we are making, what we are building, what we are cooking, what we are designing, anything that we are actually doing, if we care about it and what impact it has on others, perhaps, or if it just works the way that we wanted it to, we should be willing to accept the fact that sometimes this will not be the case, that it will not work. Someone may tell you, hey, when you look at it from this angle, it's wrong. Hey, I'll get into some of these examples. But the take home is that the test part and the debugging is fixing, right? Figuring out why it's not right and then fixing it, making it right. These are the really important, but these are the real, important parts of what we do, those of us who make or build things that others will use or consume or depend upon. So making it, we used to call this throwing it over the wall. Like if I create something and somebody else gets it and then they're like, hey, this doesn't work. You're like, well, oh well. So file a bug. There's a disconnect, and this is one reason why co-creation is an important part of most design and development processes. I think it's becoming more popular. It moves your real users and customers into the process sooner. They can give you their feedback and insights and identify real, like, hey, why this is not really useful. Other critical feedback. Sitting in a cubicle is not the way you learn how people, animals, if you're designing for pets, that's even trickier, right? Pets have a harder time describing what's going on. Unless it's a husky, I believe they are able to at least sing a tune regarding the issues that they encounter. Anyway, let's get into the links, and then we can get started through this episode, and then you can tell me with your testing results what I need to debug. First, the Innovate for Vegas homepage, innovateforvegas.org. Last week, I migrated it to GitHub Pages, and part of the process that will also be taking place for the next two links that I mentioned will be integrating the different component or the initiatives that are part of Innovate for Vegas, and then the component projects that are part of those initiatives, and having that stuff be visible to visitors to the homepage. Not every person wants to visit a GitHub repository, README file, and navigate directories, read markdown files, try to figure out where things are. So wrapping that in a more normal sort of meeting expectations in the modern era, basic, navigation expectations and so on, is part of the overarching goal. So integrating in our media is on the list. At the moment, the website looks very similar since I just moved it over. We updated our board of directors people. One person emeritus, Sean Looker, added on Sean Dean, currently a member of our board. As always, the current episode of this audio program appears on the homepage. We need to make that more useful with all episodes, not merely from Spotify. So that was a convenience at the time. If somebody were to test and say, this doesn't seem useful to people who don't like Spotify. So more options, more flexibility. That's what the web is for. It's how we, some have forgotten that, but it's how the web was supposed to work. Enabling humans, machines, to get information in ways that they can use, not simply what they are handed. Innovateforvegas.org. That's innovate for FOR Vegas.org. No punctuation. Innovate for Vegas, and then a period, and then org. So you can visit that. So hopefully that will be getting more information that is more topical for the initiatives and respective component projects and so on. As I said, projectact.info. Again, as I'm speaking to this microphone, it's not launched yet, but the dots are in place. I just need to connect them. So we've had the domain for a while. In fact, too long. I'm renewing it at the either later this month or early November. It's already been a year, so that was too much inaction for too long. Projectact.info is where, if you are a developer or maintainer, if you have a cohort, it's the Autonomous Cohort Tessellation Project, ACT. It started out as the Autonomous Cohort Transformation Project, so Project Act still has two meanings. The transformation step is actually on some investigation and reflection of late, is not unnecessary. It probably will become more necessary in what we could call a new phase of civic volunteerism and engaging normal people, individuals and cohorts, to participate in activities across their locality, across boundaries. So transforming from one person into a cohort into a more formal organization like a nonprofit, or actually pursuing an IRS determination to become a charity. These are not difficult, but some people have questions, or how, why, etc. So the transformation part of the T in ACT still viable, but the tessellation part is getting more attention. But getting even more attention, and by the way, Project ACT is ideally will become kind of a joint initiative, even though it's called Project ACT, with multiple important pieces driven by interested cohorts. So hopefully there will be more than the Innovate for Vegas Foundation sort of driving it. Although Innovate for Vegas Foundation is a fiscal sponsor of Project ACT. There you go. So it is not itself. It's more of a club project. So fiscal sponsors can be either maybe it's a nonprofit that has a pending determination from the IRS, or a fiscal sponsor can be responsible for a project or a club or some sort of a short-term or less formal structure. So hopefully if Project ACT turns into something that people are interested in, and if we need to use money for anything, that we will be a donatable entity by way of the Innovate for Vegas Foundation, which is, of course, a tax-exempt 501c3, donations tax deductible. Consult your tax professional. Our other, maybe higher priority, and I've talked about this in the priority inversion episode, agileforvolunteers.org. Agile for Volunteers is an infrastructure, methodologies that starts with the Agile Manifesto as a first principles. Not that that was much about method, but it's more principles. We are not about scoring people's efforts. The results of the Agile Industrial Complex turn Agile into a pain point for many people in the software development industry. Agile was developed by software developers, engineers, for software developers, engineers, and project managers and customers of these outputs and so on. It is often misused, abused, and people come away with a dislike of Agile methodologies when in fact the Agile methodologies are themselves fairly straightforward and completely reasonable. You get into trouble when they're used against the people that they are supposed to enable. So yeah, Agile for Volunteers is designed with those first principles in mind and to make the best use, if possible, of volunteer time, effort, and expertise, which is often difficult to come by, to enable people to enter and exit a project. Not all volunteers are going to stay working on something every day for years, right? Some people come and go, but to facilitate joining a project or initiative, somewhere in an initiative in one or more projects, to communicate where things are, what's going on, and finally, but perhaps as important, not perhaps as important, I was going to say perhaps more important, not building Agile for Volunteers for software developers, but for civic volunteers. What you are working on does not have to be software. What you're working on may be documentation or a mechanical device, some physical manifestation that goes with a project, a sign or maybe a lighted sign, right? Or like I said, documentation, language translation, visualizations, accessible user interface elements in the real world. So a visualization not always helpful if you are not a sighted person. So accounting for accessibility when making use of the real world as part of a initiative, that's not software. So oftentimes it's actually speaking to other people who have limitations. I've given an example previously, speaking to a fellow bus rider. I'm a consumer of public transit services. This other rider had glasses. They had changed the schedule recently. They said, I almost didn't catch the bus because the phone system that you called to get the schedule didn't have the new time. So I wasn't going to say he, but that doesn't really matter. They just made it because they would get there earlier than normal, right? Some buffer time given, so I said, oh, what? So you didn't look on the app? Well, vision impaired, thick glasses, not great vision. Using the phone was the best way to get the information because it's not really useful with the small writing and so on a phone screen. Well, whoever designed that software clearly didn't understand a potential fraction of a public transit customer base, people who cannot drive because of limitations to their vision. So make the app accessible. So these are the sorts of things where if people aren't accounting for your users, your customers, you end up building products that don't really do what they need to do. They match the expectations of the people in the cubicles. So Agile for Volunteers will, in its implementation, which is almost. We're using Agile for Volunteers for some stuff we're working on now. All these are open source projects, so they will be visible, hopefully in a more sort of presentable state. But it's about the workflow and about which information we need to share and how we can make use of it and so on, so that someone could come upon an initiative and say, hey, I can participate in your project occasionally, and I have a background in testing and also with language translation and localization. Okay, well, here are some tasks that we need to do. Anyway, so it's an aim to make what we're working on more transparent to potential contributors, respecting the boundaries that volunteers might have. Civic volunteerism does not pay well. Although our business model is a topic for another episode. I've talked about it before. Ideally, we will have viable outcomes that can be turned into real monetizable, commercial, maybe spin-offs. So they wouldn't be part of the foundation. They would be kind of spin-off entities that could be actual revenue generating, salary paying, or in some way compensating the hard work of civic volunteers. So as I often say, I don't want you to work for free, but I want you to be willing to work for free. Yeah, so Agile for Volunteers. Once again, Agile, no punctuation, FOR spelled out, agileforvolunteers.org. And finally, a Wikipedia page on observability. This is not software observability. There is a disambiguation link very near the top of the article. So this is just a starting point for observability. You can skim over it. It gets into some of the mathematics of observability. There's another link to quantum observability and so on. The software version of observability is probably relevant, although I didn't want to lean too heavily into software. But essentially, observability is being able to see what's going on, what's happening, what's working, what isn't working. If you think about the internal combustion engine, the stuff that really happens to make the flywheel turn is not strictly observable. It's challenging. It's very challenging to observe the combustion in the cylinder head. So piston moving, cylinder walls, valves moving, spark plug firing, or nowadays electronic ignition. Very difficult to see those things. So not as observable as could be if you see an engine cutaway, or if you put a camera in, not have take a valve out and put a camera in. You don't fire in that cylinder, or maybe you do, but you're not seeing the system running in an observable state without modifying it. So observability has some subtleties. I'll give a couple of examples as well. So observability is important in test and debug, and just in understanding how things work in general. So in case I have not hammered this point home over all of these episodes, everything we're doing is not necessarily for coders only. Some things will be codish because that's my background, but over the years, you definitely, even if you're just a coder, if you are paying attention, you will realize that the code that I am writing is worthless without the efforts of the other people doing something other than coding. Documentation, language translation, user interface design, packaging, messaging, telling the story. What is this thing? Why is it? And the list goes on. It could be a mechanical device. I've worked a lot in hardware projects. So the mechanics of the device, the reliability, all these things, they all add up. So not for coders only. My anecdotes do lead towards tech, and I say coders, tech. Right? They do lean towards tech, some code and some plain old hardware. I've done both. But this does not mean testing and debugging are notions that do not apply just about everywhere. We can add some other example areas, which we will later in this episode, with a little bit more detail. Most activities and endeavors where one is creating or making or building something would benefit from a structured or at least informed testing strategy to make sure whatever the thing is we're actually making actually works or does what it's supposed to do. If you've ever prepared, I'm going to use food a couple times here. If you've ever prepared food and not tasted it before giving it to someone else, you either didn't make it yourself or you are profoundly confident. And even then, if I'm not mistaken, even fine chefs will taste for correctness during their various production steps. So understanding what it is you're making or building and making sure that it is as intended. It's not just for beginners, it's for anyone who cares about what they're doing. What happens if the tests fail? Maybe it does not meet expectations, whatever it is you're making. And now there is some fixing to do. Hopefully there's enough information and insight on hand to do just that. So testing that doesn't yield like an option to repair only gives you a sinking feeling. And when you think about it, this is going off my notes here. The Voyager 1, which was launched in the 70s and is now very far away, was launched in the 70s, had a problem. It was able to communicate the nature of the problem, or at least enough information that it was having a problem, back to home base here on the mothership, Earth. And the scientists or the engineers or whoever is keeping track of Voyager today was able to analyze the information it received, was able to somehow reproduce or otherwise come up with a testable state here locally on planet, and then come up with a strategy to fix. So they debugged the problem and they came up with a fix, and they sent the fix back to Voyager, however many billions of miles away it is, and they were able to, in this case, probably work around the issues that Voyager was having. So by understanding your system and then making good use of the information that becomes available. So they basically had an observable system. They received behavior or some sort of an update or whatever the information was. I think it definitely included some misbehaving, if I remember correctly. So if you're able to understand what you're doing enough so that when something isn't working, you're able to affect a change and fix it, that's a good place. That's a good place to be. So what is all this observability? Well, we will most likely hear or see this with regard to software systems, especially when they're all running somewhere in the cloud. But this is really, it can really apply to anything if you think about it. And the Wikipedia article, like I said, very, very nerdy, very technical. Can you determine how a thing is working based on your knowledge of it, plus any extra windows you may have installed for these purposes? During development, you may make a version of what you're doing. We call it a debug build in the software world. In the hardware world, you may see terms like EVB. EVB? No, that's evaluation board. What is it called? It's engineering not ET, EDT, engineering device test. EVT. Engineering validation test, and then DVT, developer validation. Geez, memory's going. DVT, developer validation test, and I think those are the big two. So an EVT device is one that probably has wires sticking out of it, or maybe mounted on a board with some probe point. It's a mess. DVT units probably handed out to people to use, but they're still, buggy in development. Still might have some wires or some fixes. But this is essentially, so in that world, you're building those windows so that you can peer into the system. Often they will not ship like this to customers, although that's changing over time. Sometimes they leave some of that in. An observable system, whatever it is, can be tested more easily. But we can also examine failed tests more usefully by connecting some anomaly, like, oh, this didn't look right, with what is really happening inside. So sometimes we can get more data from these extra windows, but we can also then look through the window and replay or try to reproduce the situation and watch what's happening before and after and so on. So we get more insight into what's really happening. This can be important for a cookie recipe or a nuclear reactor. The more information we have about the what is it? What did I write here? The more information we have about the what and the how, there you go, that's a bizarre sentence, as written. The more information we have about the what and how, like what's going on and how is this happening, the better equipped we are for determining the why if things are not right. So if you don't have any idea where your control rods are, if you don't know what the water temperature is, this was, I should have put a link to it, but you're not going to listen to it anyway. The 3 Mile Island second story analysis, really interesting on what really happened. they had an observable system, but it wasn't delivering that observation anywhere near fast enough. So the people that made decisions were making decisions on information that was hours behind because of the way that their paper tape it was like a paper tape, like a calculator, cash register. It was too slow, so it wasn't providing updated information in real time and so on. So a few things went south in that case. So observable, but not really. There's more to it, but 3 Mile Island nuclear reactor, that's why I use that example. So cookie recipes are a little bit easier. We'll probably do more cookie recipes. So yeah, nuclear reactor analysis, you're not going to do that. But in the case of a cookie recipe, and it could be anything, but who doesn't like cookies? You have visibility into not only the recipe that you've selected, it may be your own, but specific ingredients used, the expiration dates and various qualities of each ingredient. Are they fresh? Did the eggs go bad? Is the sugar having a problem? The preparation and cooking environment and so on. If the cookies don't taste right, you can examine everything and then begin with debugging, right? Like, wait, did I put more salt in than sugar? Did I accidentally? And that happens. That's not so weird. So yeah, the ability to make use of the test. So now if you didn't know anything about these cookies, if you open a package of, Girl Scout cookies or Toll House cookies, no, Toll House is a mix. It could be a mix, but if you open Keebler, Nabisco, these packaged cookies from the store shelves, if they taste weird, what are you going to do about it? Some preservative may have gone south, some who knows? You can never be so sure. So you don't really have any observability into those other than the ingredients on the package. What do you really know? So now testing QA in my own early beginnings, and there's no way I could pack how this is all unfolded over the last 30 years into this episode, but not counting academia, though certainly laboratory science comes into play here to understand the scientific method and testing methodologies, especially in the context of constructing and performing experiments with results to analyze, which a lot of things are, whether you think about it this way or not. Experiments, you're going to do something and see what happens. And then you might do the same thing over and see if something else happens or see if the same thing happens. Then you can understand a little bit more about the causality of a system, the correlation of your inputs to outputs, etc. I have had many occasions to test things in the working world, some as a QA tester, others as just a creator of things, software developer, etc. And you have as well. One of my first jobs after graduating from college a long time ago was working at Apple Computer in Apple quality, which to this day I kind of wonder. Once you work, it's like working in the kitchen at your favorite restaurant. Once you see how things are done, the job market was tight. This was back in 1993. We were coming out of the Bush 41 recession. Al Gore had just invented the internet. No, he was about to invent the internets. It's based on DARPA net, so not totally new invention, but the business model, whatever. So the job market was tight, and initially I was not so thrilled to be working as a tester. That was often said in that tone. Oh, you're a tester? Oh, you're just a tester. So it was almost it wasn't a term of endearment. But it turns out that learning how a company like Apple made sure that their products actually worked, however you want to color that statement, was quite educational. If anyone remembers, this was around the time Apple switched to their Power Mac architecture. So they switched from the Motorola 68040. If you had a 040 Mac, a Quadra 950, I think it was the last of that line. So I was there when we were switching to the Power Macs, the Power PC, the joint venture between Motorola, IBM, and Apple to make a RISC-based processor for personal computers based on the IBM Power system architecture, and then the Motorola 88,000 hardware architecture and interface and so on, and then Apple being Apple, getting in the way. This was a substantial undertaking, to say the least. So how that was tested to make sure the end user, the customer of Apple, could open their new Power Mac and put the stuff that was on their old 030, 2CI or 020, 2CX or whatever. Take that stuff, put it on their new machine, and it would still work. Amazing. That took a lot of work, a lot of testing. Method and process are essential when tackling a quality assurance effort at a company like Apple at that scale. And the ability to collaborate with peers so in your testing area, add the word to. The ability to collaborate with peers. And those are your fellow testers in different areas. I'm testing audio. I'm testing user interface. I'm testing physical human interface, right? The touchpad. Actually, I was involved with the Blackbird, which was the PowerBook 520 and 540, I think it was. These were Motorola-based products. They had the first touchpad that made it into a commercial product. And I found it to be very painful on my wrist at the time. Anyway, the quality assurance effort at a company like Apple at that scale with that risk involved, it really did require the ability to collaborate with peers, so you would kind of share knowledge, communicate. By the way, testing, really, you have to have a much broader knowledge about how a system works to understand the interconnectedness of all things. The ability to communicate with the developers. So in a software or hardware case, that's the engineers across the street in the R&D complex. But it could be anybody. It could be the chef in a restaurant. It could be the kitchen staff, the line cooks and so on in the kitchen, not necessarily the chef. It could be the bartender. It could be the car mechanic. It could be the person that knows what the thing is supposed to do, and you're finding that doesn't seem to be the case. And then isolate and usefully describe findings so that they could be analyzed and debugged. This was a critical pipeline of specific, focused use and analysis, capturing of state. What was I doing when this happened? What did I expect to have happen? Some of the specifics about the configuration, the files, all the deal that would have to be on hand to reproduce the problem so that those windows could be peered through to see what was happening. And all this is critical. This is the future of Apple, was kind of banking on PowerPC working, which is why the PowerPC 601 not having an FPU was an emulated FPU of the 68881. I think it was 68881, yeah, and 82. The FPUs that were used with the 030 and then integrated into the 040, 68040, not emulated for some reason, except when John Nash came along with Power FPU. But anyway, that's I worked with him on a startup. The Newton, one of the oddest environments to work in. I did work in the Apple Newton group as a contractor, 6 months, I think it was, while I was on the C++ developer toolkit team. So the ability to write C++ code and have it run on your Newton, think device drivers or other such things. The Newton the Newton group was in the R&D complex. It was an eclectic group of people. Probably the thing that you will kind of be the most aware of. If I said this, you might go, oh, okay, I've heard of that at least. Newton script, the programming language, really looks very similar to JavaScript. And when I spoke to Brendan Eich when I was working at Netscape, I mentioned that, and he said, well, JavaScript was inspired by Self, which Newton script is also inspired by, which I knew because I had spoken with Walter Smith, the creator of Newton script. So it was a good learning experience either way. But the Newton was a new class of product. It was a precursor to the Palm Pilot, for example. Graffiti originally worked on the Palm Pilot used Graffiti, was like an integral part of the software. The Graffiti software that ran on the Newton first would run in a little box that was floating on the screen. So yeah, Palm took that and ran with it because handwriting recognition on the Newton was problematic. And then, of course, any smartphone you see today, you have a lot of the ideas that could never really be tried and tested on a Newton. The technology wasn't there yet, but the Newton was a big touchscreen. It was a big big resistive touchscreen, so that was a little bit of a problem. Today we have capacitive, which enables multi-touch and so on. So all kinds of things were, in those early days, very rudimentary, kind of not quite capable of delivering, but interesting. Since it was pushing a lot of the technology of the time to limits, surpassing them sometimes, but not practically, it was not necessarily a great representation of the ideas it was trying to implement. There are things about the Newton that I think, and people have tried to make a Newton emulators or different takes on a Newton in the modern day hardware environment running on your iPhone or your Android device or a tablet. There are several things. I think a direct move is not quite it, but the infinite scroll notepad where you'd like what would you say, like you'd swipe a line, I guess you could like draw on the screen as if to underscore I'm done with this note. So you'd have this infinite scroll, but once you drew that line, you basically say, okay, we're creating a new sort of state, a new session, I guess. So that it was kind of a line of demarcation between, okay, those are the old notes, this is the current note. So even though it was an infinite scroll, so cool ideas with that thinking, with the what's the thing when the user interface matches your environment, like a desktop paradigm. I'm totally spacing on it. Skeuomorphism. So when you can say, oh, I'm going to write on the screen as if I'm okay, dividing line on a piece of paper, like almost saying, okay, stuff in this box or above this line, cool stuff. So the Newton was an interesting place to work. Definitely interesting product, interesting times. The Newton system design was a remarkably difficult and not observable thing to deal with internally, even though it was fun for the user. That's pretty much the mark of Apple. Make it hard on the developers, easier on the users. As a developer with a non-Newton script system programmer, at a particular disadvantage outside of the actual Newton dev team. As it happens, these were customers of the C++ SDK that I was working on. So those are the people that would not have the fully broken out Newton to make it completely observable and so on. Made worse the fact that the Newton and the Mac and so on was built in the time with ROMs, read-only memory. Today we all have Flash. Oh, how much Flash is that? Well, because Flash can be updated. Read-only memory, just like it sounds. No writing, no updating, no OTA, no over-the-air updates. So if we can't update it, the system enabler scheme for the Macintosh, which also had the ROMs, the system ROM, I think it was a 4 megabyte ROM, if I'm remembering correctly. 4 megabytes you couldn't change, and you had to deal with it. So these enablers would patch at certain patch points, and there was this whole infrastructure for being able to load a system enabler or a system patch or whatever they called it on the Newton to fix bugs that were found in the shipping ROM. So most of the time development on a current product was spent trying to debug and apply fixes to test results. Oh, we found another bug. Let's run some tests and see if we can figure out the cause, find the root cause, debug, and put it in the enabler. That was the same on the Mac. There was a little communication about what the enabler was doing, so any form of testing was really brute force and imprecise. So you basically had to say, okay, I have like 1,000 things that I do myself touching the screen on this device to make sure that all of the things that I need to have working are working, because not everything could be tested in automation. A lot could be, but some couldn't. And sometimes there was this manual test suite that just that didn't have an automation path. Either somebody didn't take the time, or it was difficult to automate. Nowadays, there are tools that automate the web user interface. They automate the interaction with HTML forms and all that stuff. Selenium is a big, well-known one. But those were not available at the time. So it was really brute force. We just have to test everything, as much automation as possible. Everybody just poking on the thing just to make sure it worked. So with low observability of a system like the Newton OS, developers were left at a disadvantage, and the development process could be slow and sometimes disappointing. The Newton was the subject of much mockery. I said some mockery when I wrote this, but no, much mockery. During its time, I would suggest that while there were some real limitations, it was testing. It was testing as far as performance. Okay, so it was testing the limitations. Jeez, what do I write? I should write for myself, not for an English teacher. So it was testing limitations of the hardware, the strong arm that was inside, running at a fraction of what you find in any even low-end phone today. So the strong arm processor was the kind of cutting edge at the time, but still not enough. So it was, and the resistive touchscreen, difficult to use. It was using PCM CIA cards, which are essentially Isobus, which is slow and a pain. Not to mention, there was no Wi-Fi at the time. There was none of a lot of things. The Newton was not a phone, but it was what a phone could be without all the parts that make it a phone, if that makes sense. In other words, a smart interactive device. Oh, all we have to do is add connectivity, more storage, faster processor. Oh, okay, so make it a Pixel phone or iPhone or a Galaxy or whatever. Pick your favorite. So it was the subject of a lot of mockery because the handwriting recognizer, the part that was supposed to be the big ooh, really did not work well. Yeah, that was a mystery that sometimes worked. Observability issues made it difficult to properly test and build upon. So you really were getting this closed system that was kind of a pain, and you were better off writing Newton script apps. If you have not heard of the Newton, maybe there's a reason. Other anecdotes. While there's sometimes one person, a team, or an entire organizational structure around the QA process, that's quality assurance. Sorry, my watch was done charging and it sent my phone a notification that it was done charging. How cool is that? That's some user experience QA right there. So the QA group, in the case of Apple Quality, it was a building. It was Mariani 1 across the street from R&D. Testing the products and services is what they do. A lot of testing relies on the developer of a software product, the kitchen staff preparing the food, and maybe it's the assembly line worker installing a part in a car or some other thing built on an assembly line at a station on the line, the writer of a screenplay checking for continuity, and so on. So the person doing the building, the making, the creating, the designing, the implementing, they have a large amount of responsibility in kind of either making something testable or identifying through their own testing when things work or why they might not. If there is a different later step in the pipeline responsible for quality assurance, it's the first step, the quality itself, which is found at the very beginning of the line. Quality assurance. Quality assurance. This is to assure that the quality that you should be accounting for when you're building or making or cooking or whatever you're doing, that it's in there, right? We're just going to find out that if it isn't, we're going to assure that it's there, not ensure. That's a different responsibility. So my own story again, while working on a display controller at Philips Electronics, that was exciting. We in the lab could not enable any QA people to do anything until the display controller worked. So a display controller is exactly what it sounds like. It controls the display. Think computer monitor. Think LCD monitor, actually. A lot of instrument. How annoying. I think the Alexa product team could use some more QA, although they left that to us. So yeah, we were working on this display controller. A lot of instrumentation to enable observability. And here's a sort of ironically, or maybe too much on the nose, that's better. A display controller, one of the key observability windows is the fact that the display, the LCD screen in this case, is actually displaying something. And it's even better if it's displaying what it's supposed to be displaying. And so if you've ever gotten the timings wrong on an analog, an A to D, an analog to digital converter. So we had analog video cards back then and digital displays. So you had an analog to digital converter. You had to base your inputs to the ADC on VESA timings. You had your front porch and your back porch and all that. Your what is it called? Rescan? Scan. What is it? What is anyway, so it's when the electron beam goes back up to the top corner. So all these timings had to be accounted for when you're sampling your input signal to generate the pixel values on the digital side. So if your display controller was showing a desktop, but it was shifted over to the right with a gray part to the left or noise, like little color sparklies and stuff, that's close, but observable, right? Oh, okay, we have the timing wrong in the input. The front porch is wrong. So these are things that are observable, but not necessarily testable by normal people. Like if you're seeing that as a customer, that's very bad. That's broken. So we built our systems to be observable just to reach the point where they were testable. A lot of base testing of signals and measured values. So getting those timings correct, making sure the digital outputs were correct, making sure pixel values were correct, making sure we were doing all the right things. So once we had a stable desktop image from your Windows or Mac machine, then you could actually start testing it. Like, oh, what happens with different video cards, different cables, different everything you can imagine, just to make sure that the customer experience was what we would hope it would be. A lot of this took place in the lab, on the lab bench, where we had the machine, the equipment, the test equipment, and so on to measure and do something about, so we could test and debug right there in a very tight loop. These early considerations made testing more useful later, since we could quickly analyze findings. If a QA person or people came into the lab, or we were a pretty informal group, or maybe they filed a bug and said, hey, this video card with this cable with a properly configured display suddenly has fringing, some noise over here. Oh, okay, let's look at that cable. Oh, the cable is too long. Anything longer than 6 feet introduces some reflections, so you could start to identify potential problems to be dealt with. So the ability to debug, which means building in testing and observability, makes for a more satisfying experience when you tackle problems that are reported from others. Even today, building a database. So I did all that. Even today, building a database with multiple schema, which is one of my things I'm working on right now. Literally just yesterday, thinking about whether I want to use direct UUID v7 ID keys or some other scheme to do permalinking. Anyway, so if you have a database with multiple schema and a web application requesting data from it, adding data to it from users or other sources, you might have multiple services pulling, interacting with the database. That's normal. So sometimes it's like, I need some data display on a web page. Other times it's, I need a list of all subscribers to a mailing list, or I need to insert an affix or an updated value for an email address. I need to verify somebody's password. I need to store data in a privacy aware way so that we don't risk private, personally identifying information, all of these things, and so many more. So it is essential to provide sanity checks during this. If you've ever heard of test first, and later, and more correctly, not correctly, but more commonly known today as test-driven development, which is a good idea. You include testing of units of core base components. Make sure they work, so that if you need to make a change, if you need to, this looks like this select statement was needed another column in this join, or whatever it is, right? Whatever identifying attempts you make to debug the problem. If you make a change and then you migrate the database with that change, or more likely, you build a test version of the database and throw some test data in there. You run your TDD, your test-driven development. Testing database is a little bit tricky because of, they rely on schema and tables and whatnot. But to the extent that you're able to run your tests, I actually used pgtap for Postgres to test anything protocol, run tests during the database initialization. So building up the schemas, creating the tables, all that. Then it would verify everything at that point, then some basic unit tests. And then we could build on there with integration and so on. Databases are tricky to test, but it's essential that you do, so that you know that they work, because eventually they will be the basis on which you conduct business. So having those things in mind is essential. You don't want to have to learn how to migrate a database, to add a column. Why is the select statement wrong? Why is it doing an index scan? Why is it doing a row scan instead of properly using an index? Why is this index getting so big? Understanding the system will help with debugging any problems that you encounter in production. But a database deployed in production becomes very quickly the center of attention. So you have to kind of understand how it works. And so testing, having the instrumentation in place, having observability, forethought, can really make a difference between, and I learned this the hard way at Salon, which I've talked about previously, in my quaggling sand production. When you deploy the database and then things start going strange, that's when you learn just how much you know about your database. Understanding a system is that essential first step that I mentioned earlier. So if you understand not only what you're building, but what you're building with. And this could be anything. The cookie example, if you know your ingredients, then you might know when something is weird. Like, this butter doesn't smell right. These eggs are floating when they should be. Any number of indicators. So if you become really good at something or knowledgeable, if you develop a certain level of expertise, then when you're doing what it is you're doing, you will build in some observability so you can figure out if things go wrong. And hopefully those can be used by others. And these are various lessons that I've picked up over my career, more than I've hinted at here. And they inform my approach today. And every single civic volunteer that participates in our initiatives and component projects will ideally have a similar experience just from working with other people and having some observability notions from the start. So we'll see how that goes. But then I haven't really gone into this too much, but debugging. Debugging a software project can be quite daunting. So here again, I'm looking at software first, with a great many moving parts, dependencies, and subtle considerations that do come down to observability. Somebody sent me a text message that we'll get back to later. Will you know in a cloud environment, right? Everybody's being cool and running on Azure, Google Compute. What is it? Google Compute Cloud, GCP, GPC, Google Compute Platform, GCP. I think that's what it is. Of course, AWS, others. Will you know in a cloud environment, specifically how the load on a real machine is distributed to your virtual machine, how other parts of the cloud environment are functioning at any given time, bugs in those systems that you may not even know about, interaction bugs that may not be well understood, and so on. So it's not so easy sometimes, and you don't control a lot of that cloud infrastructure. You're building on it, but you don't necessarily know its nuances. So so that's a lot. Those are a series of audio programs themselves to deal with cloud debugging or systems debugging and so on. So let's look at the cookie example. It's a little bit easier. Suppose you are sure about your ingredients. They are fresh. The timers and temperatures were correct. You were cooking for 8 minutes exactly, and the temperature stayed at 425. You had a thermometer in your oven. It was showing 425 throughout. Even when the temperature drops, when you put the cookies in, so you open the door, put the cookies in, which are cold, or cool at least, there's a temperature drop. You see the temperature drop by a few degrees. The heat light comes back on, comes back up to temperature. You can see all this happening in the time interval that you expect. It's all good. You put your cookies on the cooling rack, and then somebody comes over and you say, hey, taste this cookie. And they're like, is there nuts in them? There's no nuts, right? Because I'm allergic to nuts. Like, nope, no nuts, nut free. So you have them test the cookie, and then they have an allergic reaction. Anaphylactic shock reaction. Get me my EpiPen. Or maybe it's a more mild, luckily, in the case of this example I'm creating from nothing, they have a very mild reaction. They feel a tickle in their throat. They say, hey, I think there was some nuts in here. I'm getting a nut reaction. There were no nuts in the recipe. I didn't put any nuts. Debugging this problem involves, so that the tester just gave you the test result. There was nuts in your product. You are not delivering the product as intended. There is something going on here that you have not accounted for, etc. Now, debugging the problems involves determining where potential cross-contamination took place. Did you have some maybe some nut? I don't know if it's tree nuts or what kind of nuts they're allergic to. So we'll just say like, I was cutting walnuts on my cutting board to put in something else 2 days ago. Well, you cross-contaminated in your own kitchen. Or did some of the ingredients you were using not come from, this flour may contain any of nuts or dairy or whatever. Why would flour have dairy? Who knows? But the fact is there are 8 allergens that the FDA indicates as sort of the top that you need to show on your ingredients or other warnings. It's nuts, tree nuts, fish, dairy, wheat, nuts, tree nuts, fish, dairy, wheat. I think soy is on there. Is that right? I can't remember the other two. Pretty close. Anyway, so if I didn't know that one of the ingredients had nuts, or you may be coming upon some other unknown cross-contamination. Like, why was there, walnut dust in the eggs? That would be funny. So yeah, you sort of need to track that down because of two things. Well, first of all, whoever was around to test your cookies is probably around now and then. So you need to get to the bottom of whether your kitchen is cross-contaminated, and you could put them at risk in other preparations if they come by for lunch or something. But more importantly, you may have discovered that some of the ingredients that do not indicate this actually contain walnuts or whatever, tree nuts, nuts, dairy, whatever the list is. I should know that list better. So there are no nuts in the recipe. That doesn't always answer the question. So that's where the debugging, you look beyond what it's supposed to do and you look at what it's actually doing. It's a mistake that cannot be made, though. You cannot release products or services or food or drink that could potentially harm people. And this becomes an issue for the inexperienced, youthful coders around you, for example, or people who are not aware of the impact of what they're working on. Oh, it works. I tested it. Do you have a record of your test? No, I just tested it. I just did the 10 things that I know test the code that I wrote because I know my code. And as Uncle Bob will say, how many of you drive in a car where the brake pedal is connected to a computer that is used to actuate the brakes? And which 10-year veteran of software development who knows everything wrote the code and hopefully tested it? So knowing your system and knowing that it works will help you avoid putting people in allergic reaction situations, dangerous road conditions. Will prevent a reactor meltdown. You never know. Debugging, it turns out, is an advanced course in learning about what it is you're making or doing or building. If you can debug, and if you debug successfully and you don't introduce more problems along the way, then you actually do know what's going on. Until then, are you sure? If you are writing something, whether podcast notes, or this is another example, whether podcast notes or a screenplay or a how-to document or a blog, anything you write today is probably spell checked, maybe grammar checked. If you're even writing it at all, you may have ChatGPT or some other chat program do your homework for you. But then what? If you have an editor or someone to look over your work, they may spot some of these some errors that were missed. The spell checker may not catch a there, THERE, THEIR. It's spelled correctly. The grammar checker may not have caught a subtlety. If you have you may have a timeline problem, a continuity error. They may find factual errors. They may find jargon that is difficult to read, a difficult writing style, or any number of possibilities that may not come through in your kind of base tools that you're using and that a lot of people rely on. So you may have missed these things or not even considered them. You may not have thought about the writing style because you're writing it, so you're totally used to your writing style. But fresh eyes looking at your screenplay or your fictional work or your TV series may say, oh, the word choices here are very odd, or this doesn't meet or fit the character. Right? You have this character being very nerdy most of the time, but now the language you're using is completely weird. So somebody who will look at this with a critical eye, but one that is fresh, not embedded into the development process, a QA person can actually offer some fresh insight, and they're playing the role of your consumer, your fans, your moviegoers, your book readers. So they're acting as a proxy to offer you a little pre-warnings, like, ooh, this doesn't sound right. Your readers will not be happy. And we can see in today's modern cinema that there's often a missing step in that pipeline. Like, oh, that movie sucked. Did anyone read it before they started making it? Continuity errors in a screenplay that makes to the screen are fuel for hundreds of hours of YouTube takedowns and complaining. Best to be debugged prior. Debug that continuity. They don't. Nobody does. But it's a very visible example of what happens when you don't QA, when you don't test, and when you don't debug something as simple, quote unquote simple, as a story. A lot of money will be spent to make that story become real, quote unquote real, in the form of a theatrical production, a cinematic experience. And if at the end of the day people are walking out thinking that sucked, they didn't even account for these three things that didn't make sense, right? All of those things can be discovered not only in the writing process, but in the actual movie production. Sometimes it comes down to editing. And if you edit out that critical component, then it wasn't properly marked and understood to be critical. So debugging can often be, like I said, more, it's a master class, if you will. It's definitely learning a lot more about what you're attempting to make by learning what does not work. But this was supposed to work, but we broke it. Oh, what are we going to do? Now we have to debug it. Now we have to re-edit. And if you ever want to hear a story about saving a movie in edit, you can read about the original Star Wars movie and how the first cut that was shown to friends and supporters and colleagues of the Star Wars, what you would now call a New Hope movie, was, I believe awful would be a kind word. So it really got saved in the edit, and it turned into the classic that it is today. And that's another form of debugging. So here are some take-home lessons, because we're already at an hour before I truncate silence. Some take-home lessons. And by the way, this was just a treatise on test and debug. There could be years of audio programs dedicated to testing methodologies on just software, much less anything else. And I believe, again, the testing and debug mindset applies to everything all the time. Understanding that whatever we did or are doing is not perfect, that there should be a way to figure that out, and then there's got to be a way to do something about that to get closer to perfect, if possible, to not do damage, to not make someone's throat close up because we forgot and had nuts. As we learn more about what we're doing, whether it is food or drink preparation, writing, building mechanical things, working in a bioresearch lab, designing nuclear reactors, or building websites and web apps, we become more and more certain of our abilities. I've been doing this for 3 years. I know what I'm doing. That is normal, but it might also be a trap. There's a classic, going off the notes here, there's a classic programmer meme. I'll let you search for it if you like. There's the senior engineer, senior programmer, junior programmer, whatever it is. The junior programmer is probably sitting at a computer cheering, hands up in the air. It works. And the senior engineer, probably hand on chin, scratching head. It works? ? Exactly. Because sometimes that knowledge, experience, expertise will tell you this should not work as apparently well as it is. Something is going on that I don't understand. So an inexperienced person accepts the win. Hey, it works. We're good. Experience tells you it shouldn't have been that easy. Never turn down an opportunity to receive constructive criticism that comes from valid tests. That is, people who complain, they go on YouTube and complain about things all day. That's noise. They probably are more interested in the views and clicks they get than in actually being constructive. Thoughtful reading, tasting of your food, reading of your book or screenplay, using your app, moving the control rods in and out of your nuclear reactor, see what happens. People who actually take the time, put in the effort, and note useful information for you, right? Those are valuable and they should be valued. Make sure you appreciate those. And always treat critique as signals pointing towards improvement. These are people who people who go on YouTube and complain. That's one thing. Someone who takes the time to say, hey, I was using your web app and I clicked on this thing. I'm using a Firefox browser and the screen, everything was shifted over and I couldn't click the button, and then it displayed some other like bold, like they give you actual, what was I doing? What did I think was supposed to happen? What did I see? Here was what and I tried it on a Chrome browser and it seemed to work a little bit better. Like, these are people who take the time to give you real information. They're giving you data, but you can turn it into information by aggregating or by investigating. These are critiques that should be appreciated because they're telling you how to make your work better. This is actually a good thing. I will say, in my experience at Apple, not every Apple engineer appreciated that. Works on my machine was a dismissive response that often was true in that instance, but ultimately destructive. These are opportunities to improve this version. They're helping you fix what you've put out there and then learn more for the next version. This is why co-creation is so valuable. Debugging is a skill that we all use daily. We can all use daily if we put our minds to it, and we can all improve that skill continuously. Believe something is working as expected or as it needs to, and believing something is working as expected or as it needs to, and determining with some testing and results that it is not the case. The ability to analyze the information at hand and effect a change, whether temporary or to work around the problem or to fundamentally change the system for the future, is the mark of real talent and expertise. That was a weird run-on sentence that I did not read well, and I totally have a typo in here. So that was awful. So to summarize what I just attempted to summarize, testing is something that a lot of people can do because often it's a very human response with a lot of variation that will give you a different test result that you didn't account for. Like, this is where user stories come in, which we're focusing on for Agile for Volunteers, which is a part of Agile, etc. Like, as a person with vision impairments, fill that in, right? Like, oh, we didn't have anyone with vision impairments test the product, so we didn't get that information. So now you can learn from that critique, right? Like, the font's too small, the color contrast is too low. There should be a screen reader compatible version of this. I'm audio impaired, so I don't hear audio cues. So there should be a flashing or there should be options to enable. You should make your products accessible, digital accessibility, real world accessibility. These are all not new. So hopefully you're accounting for those things. So people taking the time to test attentively or to be aware. Not everybody's a tester, even though they are, but not everybody knows what to do with that, what they learn. What were you doing when that happened? Oh, I don't know. I wasn't paying attention. It's still some useful information. The more, the better. Debugging is not something that most people can do, especially if they're not familiar, right? Hey, my engine is making a weird noise. That is a test, a result you can report. What do you do about it? Well, take it to the mechanic, take it to the dealer. The debugging happens by people who understand the system, can make use of observability tools, can make use of data measurements, and the list goes on. So debugging is an actual skill that we can all use daily. You can debug your dinner. Like, ooh, why is it too? I should add some salt. Why is maybe some pepper would be better. So understanding flavors, interaction of different seasonings. Okay, and then how can I take what I have and make it to be the way I wanted it to? So debugging can be that simple. Why is my bicycle chain not moving? Oh, okay, I got to lubricate. Oh, there's a little thing stuck right here from the road. Got on my sprocket. Whatever. You go through a basic debug and you find the problem and you fix it. So we all do this to some degree or another. A complicated system requires more knowledge, more observability. I was going to say observation. More observability, the ability to figure out what's going on, knowing the system, building some tools and windows, like I said, windows in place so we can look in. You can either fix the problem today to get home. As they say, if you can fix your car well enough to get home, you can deal with the rest tomorrow. So then you can, so the problem may be fixable, but there may be a systemic issue that you will discover. We can fix it in production. We'll make a better product for next time. This is where real skill comes into play. This is not about putting up a website, done, right? You can wipe your hands at the whole thing at the end. Oh, it works. And then the next day you get, this actually happened. I will close with a real anecdote. I was at a monthly recurring event and some people wrote, I put in quotes, built, pointed and clicked a no-code application, a mobile application that would enable people attending the event to sign in, so to speak, take a little survey, like, hey, I was there for this month's event, and here's a little something about me and why I attended today or whatever. And it turns out that if you entered, I want to say it was like an invalid email address or something about an email address to sign up, and then something went awry, and I didn't find the bug myself, so I can't remember exactly. So the testing was being done in real time by all the attendees at an event, so say about 100, 120 people. Some fraction of them are actually trying it. Some fraction of them have tried it last month, so they're returning and re-signing in. And the experience some were having was, hey, this is not, it's telling me this is invalid or wrong address or something. And I know it's the correct address. It was auto-filled, whatever it was. So I talked to the person who created this thing, created in quotes. I said, I think this might be what's happening. And the person said, oh, I don't know. It's a no-code app, so I have no idea how it's working. And I laugh at that because that is actually becoming more common. So the ability to accept testing or feedback, right? People have tested your product, they tasted it, they smelled it, whatever it was. They tell you, hey, this doesn't seem right, or this is what I'm seeing, this is what I'm hearing, etc. What do you do with that? And that's where the rubber hits the road, if you like. That's where the real skill can be detected. The wisdom, the knowledge and the wisdom. Hey, I pointed and clicked and I built the thing. Can you tell me how it works? No. Can you fix it when it's broken? I don't know. And that is a dividing line. That's something we're trying to focus on with civic volunteer projects and initiatives, is that people should, if they are able to take an active role in closing gaps and solving problems and elevating their communities, their friends and neighbors, people nearby them, they take an active interest, they can take some responsibility for things that work, and they can learn from those functional things when they don't work, and then they'll make them better. And the people that are using and depending on these things live around you. You encounter them in your travels, or they can come to a community outreach co-creation meeting and they can say, hey, I was using this and it works perfectly except for this one thing. And you would say, oh, I didn't even think about that. And you could sit down and fix that problem right there, perhaps, right? So when you know your systems, when you take an active interest in how they work and when they don't, when you build in observability and instrumentation, or you at least account for them so that you understand. And I'm leaning towards software and maybe hardware as I discuss this. But if you're able to, this is why source control matters for everything. If you can say to someone, hey, you're a native speaker of this other language. Did you see anything in our translated documentations for your language? And they might say, oh, yeah, I found about 5 things that were the wrong tense, the wrong gender, the wrong reference, the wrong, something, some use of language that was inappropriate or had a different meaning in this context. They can tell you things that you didn't really think about. If you could then go back to how the translation, to maybe use Google Translate or some other translation tools, or maybe maybe it was the source material didn't make it clear when it was translated to this other language. The bottom line is you can debug that and make it better. And ultimately everybody wins, because instead of saying, oh, Google's never going to fix that, there's a vast difference between that. Google's never going to fix that. And hey, Dan, I'm using your Open Transit app, and that will happen someday. And I found this problem, and I would say, oh, give me your contact information. When I get home, we're on the bus, right? I will see if I can fix it. And then if you can try it out, and we'll see if that fixes the problem, and then done. So when you can actually speak with people and show them or tell them, describe to them, and if you on the builder, maker, baker, cooker, chef side, if you can accept their feedback and say, oh, I think I know what's causing this, or I could find out, or I will speak to the team and we will figure it out and we'll tell you so that you can verify that we fixed it. The whole test debug process, when you include the people that use or depend on the things, is educational for everyone and intensely high value in a world that is only more cynical. And that sounds like I'm being overly philosophical, but you think about it. When you encounter a bug or a broken thing and you think to yourself, this is never going to get fixed. Well, that is certainly not invalid sometimes. And on that note, at 1 hour and 18 minutes pre-silence truncation, so we'll see if we can get it down to about 1:10, 1 hour, 10 minutes, maybe 1 hour and 12. On that note, I will remind you to visit our website, innovateforvegas.org. The other websites will be up and around soon. If you visit them immediately, they may not be, but Wednesday, 16 October. If you have any questions, comments, complaints, don't hesitate to keep the comments and complaints to yourself. No, that's the opposite of what I've just been describing. Join us at our office hours. Check our website for the calendar. You can email info at innovateforvegas.org, and you will hopefully get info in return. Ask a question, you shall receive an answer, and go from there. But yeah, hopefully whatever we talk about each week on this program, and if we ever have guests again, is interesting enough to make you say, co-creation, civic volunteerism, elevating my communities, innovating. Those might all sound good. Thank you as always for listening. And yes, we do need to have real transcripts. And I do need to account for our audience that cannot hear so well, or who does not want to who does not want to listen to my voice. On that note, take care.